This is a video tutorial for converting a sextant altitude of the Sun to a true altitude. So the questions from the HNC textbook, it's the 5th of January, a sextant altitude of the Sun's lower limb was taken, LL for lower limb, was taken at 34 degrees, 26.2 minutes. At the time, the index error on the sextant was 1.5 minutes on the arc and the height of eye was 21.4. As always, start with a proforma, and that way you only need to fill in the blanks. So we start with sextant altitude, to that we apply index error to get observed altitude. To that we apply a height of eye correction, known as dip, to get the apparent altitude. Apparent altitude is then corrected for refraction, which is known as the total correction, to get true altitude. So now we just fill it in. Sextant altitude, 34 degrees, 26.2 minutes. If the index error is 1.5 minutes on the arc, that needs to be subtracted. If the error was off the arc, we would add. So 34, 26.2 minus our 0 degrees, 1.5 minutes. To get observed altitude of 34 degrees, 24.7 minutes. To that we can now apply a height of eye correction known as dip. So you need the nautical almanac for this. We're taking the altitude correction tables from the start. If you have a look, we've got 3 different correction tables. Correction tables for the Sun, for the stars and planets, and for dip. So dip is the one that we're looking at now. You see that height of eye is given in meters or in feet, so make sure you're using the correct column. The question said the height of eye was 21.4 meters, so we're going to use the meters column. So right down at the bottom of the page, height of eye all the way down to meters, got 21.4 right at the bottom. Always take the correction that lies above it, so this minus 8.1 here, that is for all values between the 21.4 and 20.9. If you got 20.9 as a height of eye, you would use the next correction of minus 8. But for us, 21.4 meters, so the correction minus 8.1. If your value was larger than 21.4 meters, you can use interpolation with the tables down the side as well. So you've got larger numbers down the side to interpolate between. But for us, our correction was minus 8.1. Dip correction is always negative. So we had 34 degrees, 24.7 as our observed altitude, minus the 8.1 gives us an apparent altitude of 34 degrees, 16.6 minutes. Now we've got our apparent altitude, we can find the correction for refraction and get true altitude. So back to these correction tables, you see there's some for the Sun, some for the stars and planets. If you're using stars in your celestial observations, you would use this column. If it was planets, you would take these apparent altitude corrections and then the additional correction for the planets as well. But for us, we're using the Sun. So the Sun column is where we're at. It's the 5th of January, so you see there's 2 columns dated, so we're going to be using this column because January lies between October and March. Then you'll see within that column, we've got apparent altitudes and then values for lower limbs and upper limbs. The question told us that the Sun's lower limb was taken, so the bottom of the Sun was lined up with the horizon when that sextant altitude was taken. Our apparent altitude that we've calculated so far, 34 degrees, 16.6. So we're going to look for that in our apparent altitude column, 34, 16.6. So you see 34, 16.6 lies between these 2 values. So that means we're going to take the correction for between those 2 values. The lower limb correction, so the next set of values are for the lower limb, the ones at the end are for the upper limb. So we're going to be taking the lower limb correction of plus 14 31.8 minutes. Back onto the calculator. An apparent altitude of 34 degrees 16.6 minutes plus our 0 degrees 14.8. Now we're adding that correction because the tables had a plus sign. If it was an upper limb, you'll see that the numbers have negative signs, so you would subtract the correction. So just do whatever it is the book suggests. So we've added that on, and that gives us a true altitude of 34 degrees 31.4 minutes. And there's our true altitude corrected.